This 3D assembly of a shock absorber consists of 4 parts, including a dynamic spring, meaning that without changing any sketches or features in the spring part file, I can compress and decompress the spring by changing the position of the thumb nut. If I move the thumb nut up or down, the spring does not immediately move with it, but after using the Ctrl-Q rebuild command, the spring changes length. So, how did I do this? I'll walk you through how I 3D modeled the spring and how I mated the assembly together. As you can see, the spring is a solid model with no moving parts. The movement is done with sketches and mates. I'll start the sketch on the top plane and sketch a circle. The drawing gives me the outer diameter of the spring, but since this is a path that will be in the center of the wire, I'll use the wire diameter global variable in an equation. The outer diameter minus the wire diameter divided by 2. Then I'll use that circle to insert a helix. And I made the pitch of the helix 0.193 inches, just 1/1000th bigger than the wire diameter. I'm not going to add sweeps just yet. I'll add the rest of the paths first. For the path of the center sweep, I'll start another sketch, this time on the right plane. And I'm not going to use a helix for this portion of the spring. It'll just be a straight line. You'll see how that works when I add the sweeps. Pay close attention to how I dimension this sketch, because this sketch is what makes the spring dynamic in the assembly. First, I'll sketch a line starting from the origin. This is where the bottom helix begins. Next, I'll add a construction line to the top, and one from the origin to the bottom of the helix. Now I can add a dimension to the top construction line equal to the pitch of the helix, and then a dimension of 4 inches from the ends of both construction lines. The construction line dimension represents a helix that hasn't been created yet, and the 4-inch dimension represents the length of the entire spring, including the helixes at the ends. To make the spring movable and dynamic, I need to make the 4-inch dimension driven, so I'll right-click it and click Driven. Now I can't click and edit that dimension, but I can drag the lines to change the length. I'll exit the sketch. For the second helix, I'll use this endpoint from the last sketch and the top plane to make a reference plane and start a sketch on it. Instead of sketching another circle to create the helix, I'll just use Convert Entities to copy the sketch from the prior helix. Now if I change the diameter of the first sketch, the diameter of this sketch will change with it. Again, I'll use the circle to insert a helix and use the same parameters as before. There's just one more thing to do before adding the solid geometry, which is adding the profile sketch for the first sweep. So I'll start a sketch on the front plane, which is coincident with the bottom end point of the helix. And I'll sketch a circle and use the wire diameter global variable to define the diameter. To attach the sketch to the starting point of the helix and fully define the sketch, I'll click the center point of the circle and then the helix, and add the Pierce constraint, which is used to constrain geometry to any 3D sketches or lines where they meet the sketch plane, in this case the end point of the helix. With everything in place, I'll start a sweep using the profile sketch, and the helix is the path. And if I zoom in here, you can see a small gap, which is the result of making the pitch of the helix slightly larger than the wire diameter. Then I'll start a new sketch on this face of the sweep, and use Convert Entities again, this time to copy the profile of the wire. And I'll start another sweep, but this time I'll need to change some parameters. Like before, I'll select the profile and the line is the path sketch. And nothing happens, so in the sweep options, I'll click the Profile Twist drop-down box and select Specify Twist Value. I'll change twist control from degrees to revolutions, and I'll enter 6 as the amount. And the preview appears, showing that the end syncs up perfectly with the second helix. So I can do the same thing as before, creating a sketch on the end face and using Convert Entities again to transfer the wire diameter, and then create the last sweep. Again, you can see the small gap between the revolutions. The spring is almost complete. I just need to cut the ends to make them flat. So, to create a plane in the center of the wire diameter, I'll click the end point of the helix, then the top plane, then select Reference Plane to make a new plane, and I'll start a new sketch on it. Then I'll sketch a circle, and add and dimension a construction line. because what's important here is not the diameter of the circle, but rather its distance from the helix. Then I'll use Cut Extrude to cut away the spring to make it flat. Now, there's already an existing plane I can use at the top of the spring, so I'll convert Entity to copy the sketch I just used and use Cut Extrude again. And the spring is complete. Now I can add and mate it into my assembly. In the assembly, I have a thumb nut that is mated to the main body with a screw mate. It also has a limit distance mate. So from this base, the maximum distance the thumb nut can go is 4 inches, the overall length of the spring, and the minimum is 1.6 inches, which is the compressed length of the spring. To insert my spring into the assembly, I'll simply drag it into SolidWorks from an off-screen folder, and I'll add a coincident mate to the bottom face of the spring and this face here. Then to concentrically mate the spring to the assembly, I'll turn on the Show Temporary Axes option. Make one of the circular sketches of the spring visible, select it along with an axis centered along the assembly, and select the pop-up concentric mate. And now it's in place. But it's still free to rotate, so to fix that, I'll just select the right plane of the spring and the front plane of the assembly, and make them coincident. As it is now, if I move the thumb nut down and rebuild the assembly, nothing happens. I won't be using an assembly mate to make the spring work with the assembly. Instead, I'll do it by editing one of the sketches I made while 3D modeling the spring. To do that, I'll click the spring in the feature tree and click the Edit Part icon. Then I'll find the sketch with the dimension driven by the height of the spring. Since the 4-inch dimension is driven, I can click and drag this end point. I'll move it away from its original position, and then I'll add a coincident mate to the end point and any line on the bottom of the thumb nut. Now the sketch is fully defined. How does that simple change make my spring dynamic? Well, since that end point is now coincident with the thumb nut, it will move to whatever location the thumb nut is at. If I screw the nut down and hit Ctrl-Q to rebuild the assembly, the spring will change along with it, because the end point of the height sketch moved down with the thumb nut. And if I move it up and hit Rebuild, the spring moves back up with it. Now you've seen how to make a spring dynamically move in a SolidWorks assembly. You can use this technique for other applications as well. See if you can create a dynamic assembly of your own.